unused space automatically. In a non-garbage collected language like C and C++, you have to use free or delete to release the memory that's no longer used. Okay? So what are the advantages and the disadvantages of garbage collection? Okay? Well, the advantage is convenience. Okay, let's face it, you're spoiled. Okay? Okay? You never had to use free or delete unless, except for those of you whose primary language is C or C++, right? Okay? All right? So it's nice. It's very convenient. That's why they put it in Java, right? To make our job easier. Okay? Unfortunately, it makes it a little tougher to learn computer science because as computer scientists, you need to learn all these things. Even if you're using a non-garbage collected language, okay, you have to know, this is your trade, right? You're experts on programming, right? Okay, so you need to learn it, okay? It makes, Java makes it a little hard, to teach because, you don't have to do it in Java, right? So very convenient, very nice. The big disadvantage is that in some runtime systems, okay, the garbage collector works by basically forgetting that, there is space unused around until it runs out of space, okay? So all these objects stay around for a long time, except that at some point, you ask, for a new object, and there is no space left. Okay, so the runtime says, okay, it's time to collect garbage. Okay, so execution halts. Okay, when I was working on the Lisp system many years ago, you could basically go out to lunch. Well, no, actually, it wasn't that bad. It was only 16 minutes. Okay, on my system. Okay. And then you collect all the garbage, and then you could start working again. All right. During that time, the system was not doing anything but collecting garbage. Okay. And so, if you have deployed an aircraft navigation system, okay, that is tasked with keeping an aircraft on course and avoid colliding with a mountain, okay, or other objects, okay, this is not a very good idea for the system to go out for lunch, for an indeterminate period of time, right? Okay, so people don't use Java, okay, for safety critical applications in many cases. Or if they use these safety critical applications, they make sure that they don't create objects that need to be reclaimed, so that the garbage collector is not tripped. Okay, all right. So it's not suitable for time constraint or safety critical systems. That's why C and C++ are still the most popular languages of the day. Okay.
Is there a way in Java where we can explicitly free the memory?
I don't know actually. Has somebody tried it?
It has a destroy command that automatically calls the garbage collector.
Yeah. Yeah, of course. Yes, you can invoke the garbage collector automatically, but I don't think you can say I want this particular object released.
So okay. That will avoid, if there's something like that, we can avoid runtime errors.
Yeah. If it did that, yes.
Does the Dalvik cache?
Oh, well, that's different. Yes.
Does it have anything to do with automatic garbage?
Well, Dalvik is. Are you familiar with the concept of the JVM, the Java Virtual Machine?
Sort of.
Okay, it's a runtime system that runs Java programs basically.
Yeah.
Okay. Dalvik is another runtime system that runs on Android devices that are power starved and energy constrained and all those things. Yes. Okay, so C and C++ are the most popular languages of the day still. Okay. Now I have 5 minutes, so I can finish explaining the disadvantages and the advantages of programmer controlled deallocation. The big advantage is efficient. Okay. You have control over when objects get relinquished. When do they get relinquished? When you tell them, to go away. When you delete them explicitly or free them. Okay. Okay. So there is no performance penalty in the sense of the system stopping what it's doing and going and garbage collecting. But there are a lot of disadvantages because knowing when to deallocate objects can be very tricky. It can be very tricky. In that example over there, it's obvious, right? You allocated something, it was in that context, and then you're leaving that context and you had to deallocate it. But in some cases you have multiple pointers, right? If an object has multiple pointers and you know that one of the pointers is going out of scope, you may not know whether it's appropriate to let this object go or not. If somebody else is using that object, you cannot deallocate it, right? Okay, there is aliasing, different ways of referring to the same object, right? In programming languages, okay? So what are the errors that you can make? Well, One we already saw is the memory leak. You forgot to deallocate the object. If a memory leak is in a loop and you keep, leaking memory, eventually you'll run out of space and your program will crash. Segmentation fault, code dump. Have you ever seen that? Yes, of course, right? If you've done C and C++. All right? Okay, that's what happens. It's a very abrupt ending to your execution. And worse yet, you have no idea why your program crashed. Okay? You know that there is a memory leak somewhere. It could be anywhere in your program. Okay? So debugging, this kind of error is extremely tedious and time-consuming. Okay? You can have debugging tools that will help you, but if you don't have those debugging tools, you're just left with your source code and trying to decide where you are allocating some objects and you are not letting go of them can take days. Okay? Then there is the dangling pointer, which is the opposite error. Okay? You deallocated something that someone else was using. Okay? All right? So you decided that this was no longer needed because you went out of scope, you deleted it. So this will probably get reallocated to something else. It will get overwritten. And then the poor pointers that are still pointing that space, they'll see their data change under their nose without having done anything to that data, right? Another error that can cause a segmentation fault, core dump, the program crashes, and also very difficult to debug. Again, why? Because you have no idea where that deallocation happened. Okay? That was not supposed to happen. Okay? And then there is also another problem, which is multiple deallocations of the same space. Okay? Something is going away, and overzealous programmers decided to delete the same object multiple times. Sometimes, depending on how the free list or the heap is kept, this may be eligible for double allocations later on. Okay? Maybe put in the free list twice. Okay? And so maybe allocate it twice, to the same object. Very, very difficult, errors to find and to debug. So this is the reason why we like languages like Java that have garbage collection, because these things can't happen. Okay, with garbage collection. I made a big deal last time of pure versus hybrid object-oriented languages. I told you why I like teaching Smalltalk and C++. And I said Smalltalk is pure, C++ is hybrid. Smalltalk is statically typed, C++ is dynamically typed. Now this should make sense in the light of today's discussion. You understand the difference between static typing and dynamic typing. But the distinction between pure and hybrid is explained here. In a hybrid language, in a pure language, every type is a class. So there is no data types except for classes. And every function is a method, okay, not a standalone function. Every function call is a message. Every expression is a message expression. And the program execution is usually started by sending a message to an appropriate object. Okay, so that's the pure, pure object-oriented language, essentially only embody the object-oriented paradigm and nothing else. In the case of hybrid languages, the object-oriented constructs coexist with traditional language constructs. So you can avoid using classes if you want, because you also have traditional functions and function calls and main units and all that. So C++ is hybrid because it incorporates C. You can write C code and compile it with a C++ compiler and call it C++ if you want, and that will be fine. Okay, Smalltalk is pure, Java is mostly pure. Okay, all right. So that's the difference. Okay, remember it's an object-oriented language if it just has those features, classes, polymorphism and inheritance, and so a lot of languages that differ deeply with each other, can call themselves object-oriented. The purpose of this class is to expose you to the breadth of the spectrum of languages. I'll see you on Tuesday. Have a nice long weekend.